Or not. Mr. D would like to sell his gold necklace and his bracelet to buy his wife a new wedding ring. Mr. D weighed both items using separate scales. So the necklace weighed this much, the bracelet weighed that much. State each measurement with its uncertainty, right? So if it's not a picture, if it's just a number, then you got to go out by that number, okay? So we can say that this necklace weighs that many grams. Get your precision from that. Your precision is 0.001, right, grams. Then you get your uncertainty. You go plus or minus. You divide your precision in half. That's 0.0005 grams. Akil, off your phone now, okay? Thank you. Then it's 9.23 grams, right? Plus or minus. The precision is 0.01 grams, right? It's to the second decimal. You divide that in half, you get 0.005 grams. And then you have both of them, you stated both measurements with their precisions. So let's do B. What's the total weight and the combined uncertainty? Bless you. We add up the actual weights, and each one of them has their specific uncertainty that comes with it, okay? You add these two together in this case because you're combining the weights of them, right? If you do that, let me just go to my key here. That's 22.180 grams, plus or minus. If you add this up, it's 0.0055 grams, okay? And there you have it. That's the combined weight and the combined uncertainty. So you always add up the uncertainties no matter what, okay? No matter what happens to the actual measurements. What's the greatest combined weight? So they're asking for the maximum weight. So you basically just add these two together. Okay, you add that up, you get 22.1855 grams, okay? Some of you got thrown off by volume or mass or anything like that. This is mass, right? If it asks you what's the greatest combined mass, that's the combined weight. If it's volume, it's amount you can fill in, right? So milliliters is cubic centimeters. You don't have to worry about it too much. Usually they keep it pretty straightforward. Even if there's conversions, don't worry about that too much. Just know how to do the basics, right? How to add the values and figure out the precision and uncertainty. If Mr. D had 5 necklaces weighing this much and 3 rings weighing that much, read carefully here. What would be the combined uncertainty? Okay. So we have 5 necklaces. We're going to multiply it by the uncertainty for each necklace. We already figured that out up there. So that's going to give us a combined uncertainty for the necklaces. There are 3 rings. We already know the uncertainties from A, right, from the previous part. So we just multiply this across. This gives you 0.0025. Please do not round in this unit. Okay, do not round no matter what. 3 times the uncertainty for the rings would be 0.015. And what do we need to do with these two numbers at the very end? You add them. Okay, you add them up, you get 0.0175 grams. This is just the combined uncertainty, okay? If it asks what's the combined weight and the combined uncertainty, right? Like if it says it that way, you would have had to obviously multiply, right? Go 5 times the weight of a necklace, 3 times the weight of a ring, and add that up as well. So there'll be another number in front of it, plus or minus the combined uncertainty, right? So be ready for something like that. Let's do one more. Or are you good? You good to go with the AC, or one more? Some of you are like, no, yeah, sure, one more. Okay, well, if you're ready, then you're ready. You can just, this one, let's do the one on page 29. Colm is preparing liquid fertilizer, right? There's a bucket marked in half liters. I put that in bold and underlined it. What is that for us? The bold, underlined. If it says markings or it's marked in, that is your precision, okay? So basically they gave it away. You don't have to guess. You don't have to look at the number. It says marked in half liters. So the precision is 0.5 of a liter right there. So the bucket has half liter increments, okay? With 4 liters of fertilizer mixture. Colm uses a small jug marked in, so here it is again, 125 milliliter increments. Okay, so that's that one. So they're basically giving you the precision for that small jug. It's giving it away, guys, okay? You don't have to look at the numbers or how much is in there to figure it out. They gave it to you. And so we're using that jug to remove 375 mLs, right, from that 4-liter bucket. Write the volume of liquid. It's like the amount of liquid, that's the same thing, right, in each container in this form, right? You want it in this format. That is very important. They will often have this added to the question. Then you know, okay, it's supposed to look like that. So let's do that. A, if you don't mind, draw your bucket. Yeah, I know. Not getting an award for this one, right? But basically what we're saying is it's marked half a liter increments, right? So 0.5, 0.5 of a liter. Okay, that's what it's saying. Whereas the little jug, okay, if you just look at that little jug, the markings here are 125 mLs at a time, right? So it's 125, then it's 250, and so forth, right? So that's what it's saying. This is the jug. And so now it's telling us that this bucket has 4 liters of fertilizer in it. So we go 4 liters plus or minus. Okay, this is a common mistake. Don't write this part down if you're writing this down. That's a very common mistake. Students are like, oh, the precision is 0.5, just tack it on. Remember, uncertainty, that's what goes behind here. So you got to go, precision is 0.5, therefore the uncertainty is 0.25 of a liter. Okay, so that is what I would expect you to add to that question. So this is the bucket. Okay, then we have our jug. Okay, so how much is in the jug? 375 mLs, milliliters. We're going to go plus or minus the uncertainty for that jug. The precision is 125. We already determined that earlier. The uncertainty is half of that. Is it 67.5? 67.5, or did I get that wrong? I think I got that wrong, right? My key is a little different than the way I'm solving it here. I think my key is, it's in liters. Okay, got it. But in milliliters, that's what we got, right? Let me see here, 125 divided by 2. 62.5, sorry guys. It looked off. So that's what you add here, 62.5 milliliters, okay? This is the jug. So there you have both of them stated with their respective uncertainties. So now that you draw from the big bucket, right, use the small jug to take from that big bucket, what are we going to have to do in terms of the actual amounts? We're going to have to subtract 375 from 4, right? And what are we going to do to the uncertainties? We're always going to add them no matter what, okay? Just sitting in front here. I just changed it a little bit. Okay? Now the problem is this, and you're not going to encounter this, I've never seen this on a provincial exam. Okay? I've never seen that, but 2 different units. I don't know if you remember, 1 liter has how many milliliters? 1,000 milliliters, okay? So if you have 1,000 milliliters, you just basically, I'm going to multiply this by 1,000, both of these. So here we go. This is B here. It's 4,000 milliliters, plus or minus. I'm going to multiply that by 1,000. That's 250 milliliters. Turn it all into milliliters. Go minus 375, plus or minus 62.5. So we're going to subtract this. And we're going to add these two, as we always add these two up, right? That's 312.5 milliliters. So this is what we wanted to state here in this particular case. That's how much is left in the bucket with the uncertainty here. C, what's the maximum and minimum amount left in the bucket? Okay. To get the max, we go 3625 plus 312.5. To get the min, we go 3625 minus 312.5. I don't know what happened to my my key doesn't seem right on this one. So this gives you the max is 3937.5 milliliters. It's all in milliliters here. And if you subtract 3312.5 milliliters. Okay. And there you have it. So it's a lot of work. These ones involve the whole process, but it reviews precision, it reviews uncertainty, and the fact that every measurement should have an uncertainty that goes with it. Okay. All right, we're going to stop here.